Question number 9 says, question number 9A says the diagram below shows a circle with center O and the points P, Q, L, and M lying on its circumference. We're told that Ln is equal to NQ and that Rm is a tangent to the circle at L. So L is the point of contact. And angle is 63 degrees. Explain why angle NQL. Explain why angle X and angle NQL. Angle NQL is this angle here. Why are they both equal? So, well, first of all, they're angles in the same segment. Angles in the same segment subtended by the same arc or by the same chord are equal. So if P is X, the angle at Q is also X. So I can say angle X is equal to angle NQL because they are now you could stop here or you could add subtended by the same arc. All right, so they're equal because they're angles in the same segment subtended by the same arc, and angles in the same segment subtended by the same arc are equal angles. We're to determine the value of each of the following angles, show detailed working where possible, and give a reason for your answer. Angle X. What's the size of angle X? Now, to answer that, I'm going to use this theory. Or this theorem. All right, so if I have this, and the angle here is X, and the angle here is 63 degrees, the angle X is equal to 63 degrees. And the reason for that is the 63 degrees is called an angle between the tangent and the chord at the point of contact. And the angle X is called the angle in the alternate segment. And those two angles are equal. So angle X is equal to 63 degrees because the two angles, the angle between the angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment. Now, the angle Y, what is the angle Y equal to? Now, to find the angle Y, remember we already established that this angle is also 63. You'll notice that triangle LNQ is an isosceles triangle. N would be the apex. QL is the base. And the two base angles of an isosceles triangle are equal. So if the angle at Q is 63, the angle at L is also 63. And since the angles in a triangle add up to 180 degrees, Y would be equal to 180 minus 63 plus 63. It's 180 minus 126. This would be 54 degrees. And what's the reason? Triangle NLQ is isosceles, is an isosceles triangle. Triangle NLQ is an isosceles triangle. That brings us to B. All right, so at B, we're told that 2 ports, E and G, are on level ground, 45 kilometers apart. The bearing of E from G is 302 degrees. So bearing is measured clockwise, starting from north. So from north, going around, all the way around to E, that's 302 degrees. A ship is anchored at F, some distance away from G on a bearing of 228. So the bearing of F from G is 228. Going around to F, this is 228 degrees. All right. Immediately, I can find in here. So let's see what's going to ask. What they're going to ask. This says on the diagram, insert the angle 228 degrees, the bearing of F from G, which I've already inserted. Now, the value of, we're to determine the value of angle FEG. To do that, I would first determine this angle. FEG is this angle I want. That's the angle I want. But to determine, I'm going to first determine alpha. Now, alpha is actually 302 minus 228. So alpha would be 74 degrees. So this is 74 degrees. Now, the angle at E, angle FEG would be equal to 180 minus 52 plus 74. It's 180 minus 126. So this would be what, 54 degrees? So the angle here is 54 degrees. What else were we asked? To calculate FG, the distance the ship is from port G. So we need FG, let's call it Y. To do this, we have 3 angles on one side. This is clearly I'm going to use sine rule. So Y over the sine of 54 is equal to 245 over the sine of 52. That's sine rule. Y over the sine of 54 is equal to 2 how much? 245 over the sine of 52. Our objective is to find y. Bring this up here. And we get y is equal to 245 sine 54 over the sine of 52. So y, which is GF, would be equal to and our answer is 251.5 kilometers. All right. Triple I says, indicate the point F on the line EF such that indicate the point H on the line EF such that GH is the shortest distance from G to EF. Now, you will get the shortest distance from G to EF. The shortest distance is the length of the line that is going to form a right angle with EF. The shortest distance would be the length of a line that is going to form a right angle with EF. So this would be H, and this angle here would be 90 degrees. The shortest distance from G to EF would be the length of the line GH such that GH forms an angle of 90 degrees with EF. Remember, we already found Y to be 251. Was it 0.5? 251.5 kilometers. All right. Now we want to find GH. Let's call it X. That's opposite to the 52 degrees. And the 251.5 is the hypotenuse. The trig ratio that includes opposite and hypotenuse is sine. So I'm going to say the sine of 52 is equal to opposite x over the hypotenuse, which is 251.5. If I have one fraction is equal to one fraction, I want to get rid of the fraction, I would cross multiply. 1 times x is equal to 251.5, the sine of 52 degrees. X, which is GH, is equal to and I'm getting 198.2 kilometers. GH is 198.2 kilometers.